Okay, let's try a higher order differential equation. We'll just go up to a third order differential equation. So let's say we had x cubed y prime 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 minus 6y is going to equal 0. Okay. Now remember, whenever we're doing this problem, I'm going to say, I'm going to let y equal x to the n. Okay. So what would my y prime 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 be? So okay, so the first derivative is going to spit out an m. Okay? Well, then the second derivative, all right, so it's mx to the n minus 1. Okay? If I take the next derivative, that first n is still staying there, but then it's going to spit out an n minus 1 and drop it down to n minus 2. That's how we got on the previous problem, at n times n minus 1. But then on the third derivative, what's it going to do? It's going to spit out an n minus 2, and it's going to drop the power down to n minus 3. So 3 derivatives, it drops it down in 3 terms. So the third derivative would be m minus 1 times m minus 2 times x to the n minus 3. 3, not 2, 3. Okay? And that's that whole n minus k plus 1 business. It just goes down by 2 on these, but it goes down by 3 when you're talking about the power of the x to the n. Okay? So, if I'm looking at, this is the problem that I'm looking at. X cubed y prime 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 minus 6y, which equals 0. All right, now this thing would become x cubed m minus 1, m minus 2, x to the n minus 3 minus 6 x to the n, which equals 0. Okay. Well, the x cubed and that x to the n minus 3, the negative 3 and the positive 3 are going to cancel each other out. So we're left with m minus 1, m minus 2, x to the n minus 6, x to the n, which equals 0. Okay. Say we go ahead and divide by x and let's get it out of there. Okay. Or let's just pull it out. So, all right, just ignore the x and the m at this point. So this becomes m, this is m squared minus 3m plus 2 minus 6, which equals 0. Right? So that's m cubed minus 3m squared plus 2m Okay, so we have a third degree polynomial. Right? Now, I don't normally put these on tests, but let's go ahead and work through this thing. So whenever I look at this problem, I see that I've got a negative 6 at the very end. Normally, the one at the end is kind of the giveaway of what you can make as the guess of how you want to start to factor this thing. And so if I see that negative 6 over there, I immediately assume, well, this problem is in some way going to involve a negative 2 possibly, or a negative 3. And also see that negative 3 right there. So that's kind of like a hint saying, you know what, let me try m minus 3. Let me try a polynomial long division with m minus 3. So, let's try it. I mean, those are normally pretty good clues, but it's not necessarily true that it all works out. Like in this case, choosing 2 wouldn't actually work. Okay. So let's try -3. All right. All right. So I'm going to try dividing by m minus 3, and we're dividing into m cubed minus 3 m squared plus 2m minus 6. Okay. Now remember, you're multiplying, you want to take whatever this is and you want to multiply it so it cancels that guy right there. Remember, you multiply it and then you subtract it. So to get to m cubed, I'm going to have to multiply by m squared. Right? So I'm going to multiply by m squared. Okay, that would be m cubed minus 3m squared. All right, negative, positive, great, that just came out to 0. Okay? Okay, so now what I'm going to do is I'm going to pull that down. Okay? And now I have to think about what would I multiply this guy by to get to that? Okay? Well, what would I have to multiply by? I'd have to multiply by 2. Okay. So that would give me 2m minus 6. Draw the line underneath, and then switch it like so. And man, we don't have any remainder left. So what does this thing factor into? Well, our original thing was this right here. If we factor it, we're going to get m minus 3 times m squared plus 2. Oh, I'm off the screen, sorry. Okay, so that's what we figured out. We figured out that that is how we're going to factor this thing. But then you have to think about, well, how would I factor m squared plus 2? Well, if you said m squared plus 2 equals 0, you'd subtract 2 from both sides. You get negative 2 on the other side. And then when you try to take the square root, you're taking the square root of negative 2. Okay, so that's going to be plus or minus I root 2. So this thing is going to become m minus 3 times m plus I root 2. Now m minus I root 2. Okay? So we have 3 and plus or minus I root 2. Okay, so those are the m's. Okay. So y, okay, the first one's pretty straightforward. Okay. Now the next portion of it is going to be complex. It has no real portion to it. So we're going to have a C2 and a C3. Okay. Now plus, I'm going to try to squeeze this in. Root 2 natural log of x. I'm going to run out of room, so I'm just going to go ahead and write it below us. And then plus C3 sine and this right here, that's actually the answer that we're looking for.